Okay, today's a big day. I know you're getting ready for your kinematics test, but we are about to move on, and we are about to move on into forces. Remember when we started mechanics, way back when, we said there were three parts. The first part was kinematics, which was the study of motion. We've been studying motion a lot. The second part is statics, which is the study of forces on objects at rest. And you have this written down, I think, somewhere, or you should. And the third part is dynamics, which is the interaction between forces and the movement that they cause. So we're going to look today at statics, and then after we get through your test and the next day, we're going to go into dynamics, okay? So we're moving into the next section, and you're going to love forces, I think. Okay, so this is the study of forces of objects at rest. So today is statics. All right, first we have to define a few terms. One term is mass. What is mass? Those of you in chemistry maybe have already heard a definition for mass. Mass is simply the amount of matter an object has, okay? And you probably might want to write a few notes down here. The amount of matter an object has or contains. It does not change when you move it from place to place. Does not change when you move it. And I'll explain what I mean by that when you finish writing it down. When you move it from place to place. Does not change when you move it from place to place. Okay, and for us in the metric system, it's usually measured in kilograms. I know chemistry often uses grams because they're dealing with chemicals. We use kilograms because we're dealing with people and boxes and crates. And okay, now what I mean by it does not change when you move it from place to place. Here on the surface of the earth, standing in my classroom, I have a certain amount of mass. If I went to the top of Mount Everest, assuming I was airlifted there, I have the same amount of mass. I'd have the same amount of mass on the International Space Station. My amount of mass doesn't change unless I physically lose mass. Like I run a marathon or I climb Mount Everest, then by the time I get to the top, I'm probably fewer kilograms than I was at the bottom. Or if I eat 8 liters of ice cream, I'm probably more kilograms than I was at the bottom. So the only way you actually change an object's mass is by physically taking mass away or physically adding more mass. Okay, I say that because that's different from our weight, and we'll get to our weight in a few days. But our weight changes depending on where we are, but our mass does not. Okay, so that's one word that we'll use a lot. Another word that'll come up fairly often is the word inertia. And you've maybe heard the word inertia before, I-N-E-R-T-I-A, inertia. Lots of times students tell me they've heard it because they watched Bill Nye, the science guy. Sometimes people have heard it in sports, maybe. You have to overcome someone's inertia. Really, we all have inertia. Inertia is the natural tendency of an object to remain in its current state, whether that state is at rest or in motion. So the natural tendency of an object to remain in its current state of motion. If its current state of motion happens to be it's at rest, that's fine. So the natural tendency of an object to stay in its current state of motion. You have inertia. That's why when you're lying on the couch and a parent says, could you take the garbage out? your natural tendency is to stay in your current state of motion. It's why when they go into your bedroom in the morning to get you up sometimes, your natural tendency is to stay in your current state of motion. But it's also true about, like, some, maybe think of a heavy object that's moving pretty quickly. It's hard to stop it because its natural tendency is to remain in its current state of motion. And the more mass the object has, then the more inertia it has, right? The bigger the object, the more bigger its natural tendency, the more difficult it's going to be to change that state of motion. Your parents would probably agree. They probably have figured out by now that when you were 4 or 5, it was a lot easier to get you to change your current state of motion than it is now. Okay, so inertia, the amount of inertia an object has is directly related to its mass. So it's the amount of inertia an object has is directly related to its mass. So the bigger the mass, the bigger its inertia. Okay? So how does an object change its inertia? How do we change an object's inertia? We change an object's inertia, we change its state of motion by applying something that is called a force. Okay? Now, for years, scientists debated about what forces were. Some forces were easy to see, right? If I push this object, you see that I'm putting a force on it, right? If I push a heavier object, whoops, that didn't work well. If I push a heavier object, I might need more force to actually move it, okay? So those types of forces where they could actually see the contact, they were easy for the early scientists, the early physicists to understand. The forces they had a harder time with were the forces that are called non-contact. So there's 2 categories of forces, contact and non-contact. So contact, you're actually touching the object, exerting the force. Non-contact force would be a force like gravity, right? And think of the story of Newton watching the apple fall from the tree. The force of people had a hard time accepting that that apple fell because the earth was putting a force on it. And they're like, the earth isn't touching it. The apple's up in the tree and the earth is like down below. How could it possibly be putting a force on? So it took a long time to convince people about non-contact forces. They're forces that act over a distance without the object that is exerting the force touching the one that's experiencing it. So gravity is one of those. If you think of magnets, magnets are forced like that, right? If you have a big, huge magnet and a little paper clip, the paper clip begins to feel the force from the magnet before it touches it. Okay, so contact and non-contact are usually the way we separate forces. But we still haven't said what is a force. And if you were in class right now, I would ask you, how would you define it? Because I know you've heard of it, but you've maybe not thought of, how do you define a force? How would we explain it? A force is simply a push or a pull. Oops, I forgot the in both cases. A push or a pull on an object. Doesn't say anything about you have to touch the object, but the object experiences a push or a pull. And the rest of that statement is that may cause a change in motion. That may cause a change in motion. It doesn't necessarily cause a change in motion. I could be standing here at my front desk where I am right now, and I could be pushing on this front desk with all my might. I am definitely exerting a force on it, but like you come back the next day, I'm still here pushing, the desk won't have moved, right? So if I pick a smaller object, I could probably cause a change in motion. But if I pick